Hello friends, myself Sandeep Abang, lecturer from Mechanical Engineering Department working at the CSMSS Polytechnic, Kanchanwadi, Aurangabad. Today we are learning about the heat treatment process, how heat treatment process is carried out. The learning objectives of the heat treatment process are as follows. First, the learner can understand the process of heat treatment. The learner can understand the temperature range, uh, change of phases, identify the microstructure and behavioral of material, and changes in mechanical properties, chemical properties, as well as physical properties. The heat treatment is defined as the sequence of heating and cooling to get desired combination of properties in the steel. It is nothing but it is the sequential procedure of heating and cooling to achieve the required properties of the material of or steel material. The these properties are achieved or can uh, get by the phase transformation and change in structure. How the microstructure of the steel is to be changed and which phase is to be occurred in the during the heating and cooling. There are some advantages and disadvantages of the heat treatment process. The advantages are the resulting products has a better durability, machinability, toughness and strength or other mechanical properties. It can be weld easily and the wear resistance increases, overall lifespan of the product also increases. And the disadvantages are as follows. The initial setup of equipment or running cost is high. The metal may get oxidized during the heat treatment and some of the properties are lost in some cases, and some of the cases carbon are remaining in the material, so it get harder. And the heat treatment process is time consuming process. Diagram, which is a very important diagram for the heat treatment process, in which our TTD diagram is also called as time temperature transformation diagram. In this diagram on x-axis time is shown and y-axis temperature is shown, and again in the middle region it shows the phases or transformation is being occurred here. Okay, so in vertical axis or in y-axis it is shown by temperature, and we know that the recrystallization temperature or heating temperature or eutector temperature is the temperature at which the phase changes occur or started at this temperature to change the phase. So the eutector temperature or austenitic temperature is the most elevated temperature at which the transformation or phase will be changed. Okay, or we are heating the temperature, we are heating to steel above or below this temperature or above this temperature, and then it will cool slowly or as per the required material. So in the first line indicates that the starting phase, the middle line indicates that the mid phase or 50-50 transformation being occurred, and the third line indicates that the final or 100% transformation being occurred. Okay, in upper region, the upper region is called as perlitic region, the middle region is called as benetic region or benite is to be going to form, and the third region is called as martensitic region. In the perlite, whenever the first line indicates that it is the perlite, it's going to be start perlite 50% perlite and 50% austenite is present in this at this stage, and it is a perlite finish, or it is the finished stage at which perlite is formed. Okay. Perlite is a very soft phase or ductile phase in which soft material is occurred. After that, again again in below the perlite, the bainite is formed. The bainite is a some slightly harder than the perlitic phase, in which again this line shows that bainite is going to be start. This middle line is 50% perlite, 50% bainite is present, and third line indicates that the 100% bainite is formed. And after that, the third in the third region, or at the bottom region, the martensite is going to be formed. The martensite is the phase in which the material or the steel material becomes very hard, uh, strength, which has a more strength and brittle. So first line indicate that martensitic start, 50% martensite is formed, and martensite finish. So it is a TTT diagram which is very important for heat treatment process. Without this, heat treatment process cannot be. First one is the annealing, second one is normalizing, third one is the hardening, fourth one is the tempering, and fifth one is the surface hardening. We will discuss in next videos in detail. Broad applications such as aircraft industry, automobile manufacturing, defense sector, forging industries, heavy machinery manufacturing industries, and powder metal industries. Thank you very much for watching my videos. We will we will discuss again later with upcoming videos of heat treatment process, such processes such as annealing, normalizing, etc., etc. Thank you.